Okay, we are talking about the stoichiometry. Yes, we are in the middle of stoichiometry. Let's say one direction here. A plus B. This could be the coefficient for each direction, because P plus Q, like this. As we talk, these are brackets. These are products, right? All right. Ratio is very, very important. Ratio. It could be moral ratio. It could be mass ratio. So in this case, let's say moral ratio, and this is mole of P product produced divided by mole of A. Let's say just focusing P and A removed. Right? So this could be nu P, nu A. Yes. And also the mole of P produced can be calculated with nu P, nu A multiplies mole of A removed. And if you want the mass of P produced, or the same thing, nu P, nu A, but here we need to multiply molecular weight of P and molecular weight of A, then multiplies mass of A removed. This is very simple. You guys already know from the general freshman chemistry. All right. So here, let's see ratio R late. We already have talked about the weight. So the weight P based on this equation, you can have nu P, nu A. All right. So this can be extended to whole this one also. Just multiply the molecular weight here. When positive, this means something produced. And minus means something removed in the reactor system. All right? Okay. Using all the materials we have run previous class, now let's move to the reactor. Hey, Tom, can you give me some example of the reactors in environmental system?
Reactor.
Yeah.
Nuclear reactor.
Huh? Right, that is right. Nuclear reactor is reactor. Sort of. Anything else? Carrying over there? You know my question?
I understand the question. I don't know the answer.
Okay. What could it be? What is the example of the reactor in environmental system? Well, nuclear reactor is a reactor. It is anthropogenic, man-made in a reactor. But I am talking about the environmental. Environmental means kind of not man-made, God-made type of reactor. What could it be?
Any living cell is a reaction.
Living cell. Yeah, that could be one reactor. All right. Anything else? Well, living cell is kind of microbial, biological reactor, but we are dealing with some kind of geoscience or earth nature type of system, right? So. What kind of reactor we are dealing with, we want to deal with. Is the river can be a reactor? Or is the lake could be the reactor? What about the groundwater plume? Do you know what the groundwater plume? Groundwater plume? Well, some of you, mostly sophomore in civil and environmental engineering, you will have geotechnical or soil mechanics, maybe a junior year. Well, this is surface of ground, and always underground, underworld. I really like the movie Underworld, vampire and always werewolves, fighting each other, thing. Well, anyway, the underworld actually consists of the dry part and the wet part. So you can see the both actually floating at the surface, right? This is kind of the surface of the fully saturated zone with the water, groundwater. So we call it saturated zone. Saturated zone. And this is non-saturated zone. So here, actually, you know, all the water, all the flowing thing actually flows. If the surface is flat, it stays, but it has kind of, you know, slope. It always flows, right? So groundwater, actually, it is kind of river. You cannot imagine, but this is river. Because there is, this ground actually consists of the soil particles. It has pore. So the groundwater actually flows through the pores. But compared to the river water, the groundwater flow is very slow. Let's say, what is the speed, velocity of the Gakcheon River water? Any guess? Time? Over time, but this is, you don't want to answer my question. Just guess. Meter per second? 10 meter per second? It is too fast, right? 1 second, it just goes 10 meter. Wow, that is very fast. Think about the Usain Bolt's, you know, world record of the 100 meter sprint. What's his record? It's 9 point something, right? So that means he goes 1 second, maybe 10 meter per second. That is the Gakcheon River flow has the same speed to Usain Bolt's, you know, speed. It is very fast, right? So maybe 1 meter per second, maybe, right? Sometimes, you know, the groundwater flow is 1 centimeter per minute or hour, but it flows. Important thing. So we call this flow as groundwater flow. The ancient Greek philosopher Plato talked to the people. There is very big river under the ground. Yeah, Plato knows, you know, groundwater flow, you know, before Christ born, actually. So this is kind of, you know, a record. And here, well, you know, there is Han River flows. So if you just cut it, this section, well, we can actually take it as a record. But this one is kind of continuous, right? This one also continuous, right? So the reactors you can see in environmental system, they are usually continuous system. But what about the this system? Do you like drinking alcohol, or do you imagine, or do you have a kind of dream? You know, sometimes I will brew, you know, beer myself. Schweppes. That means you agree with me, right? Well, sometimes, you know, you just check the advertisement of the American, you know, broadcasting. You can see lots of self-brewing system. So they sell kind of very small keg with plastic, and then they sell the microorganisms, you know, very small amount, and then they sell kind of hops and some kind of barley, so that you just fill the water at first time, and then fill this microorganism. Then you add hops and barley, depending on your preference. Then put it maybe 10 plus 10 Celsius degree. What happened? The fermentation process happened, right? So this keg for brewing a beer is kind of reactor. Compared to this reactor, what's the difference between these two?
Contained.
Huh?
It's contained.
Contained. Yeah, right. So as she said, this is you know, something's provided by this starting point, right? But this, what about this one? you just put up everything here, and there's no, addition anymore, and no out anymore. Here, always, the some kind of flux entering in and entering, leaving out. So we call it continuous reactor. We call it batch reactor. Batch. So this is the type of reactor. So reactor is the place where reaction occurs. Yeah. So as I already talked, river and groundwater plume and even waterfall could be the reactor. So now we would like to design this reactor.
Professor, so what is definition of
What is definition of what?
reactor?
Reactor. The place where the reaction occurs. Yeah. As we already have taught, there is batch reactor and continuous reactor. Before starting, do some general approach. I think nowadays, when I was, graduate student, the environmental issues are kind of very popular. So everybody, have interest in the what kind of contaminants are, found from the groundwater. So analytical chemists and even organic chemists stick to the environmental issue. They really, wanted to find out new chemicals actually. But nowadays, the interest actually a little bit shift to the energy. But the story actually like that before 1970s, when the Arabic country gathered and they decided that we want to control the production of the gasoline and petroleum. Then such kind of protocol struck the world actually. Then United States, Soviet Union started to, shrunken their economic size, and there is very big, energy, problem popped out around the 1970s. So at that time, well, all the chemical engineers and all the, chemists focusing on the energy, alternative energy. So if you just check the alternative energy, biofuels and wind, power and the sun, photo type of energy. Well, mostly they were already developed in the 1970s. So you may be wondering, because biofuel, you may think that could be nowadays, products. But it was already the procedure, the production procedure already developed in the 1970s. Even CO2, as I already taught, not Hitler era, they really have very strong interest in the to degrade CO2 and make the CO2 very beneficial chemicals. Even 1940, they have strong interest. But problem was, you guys can make, synthesize a very beneficial chemical using CO2. As I already talked, problem is you need to add more energy to synthesize such, beneficial chemical. That is the problem of the day, actually. If you can develop catalyst well, good catalyst, you can lower the activation energy, and then you can actually provide less energy, and then make some beneficial chemical from CO2. That is kind of material scientist is doing nowadays. The chemists also do the same thing. But most of the basic chemical theory already developed, environmental theory already developed 1970s, even 1950s. But nowadays, I think the oil company and Arabic country just rise the game and issue some specific energy problem. Well, I think I don't think the energy interest of these issues cannot be last maybe 10 years. Maybe environmental issues rise again. This is kind of cycle. It is very, very interesting. So when I was college boy, chemical engineering is just like the final destination actually. Maybe at the top, like double E actually always there. And then, material science is also, kind of the last destination. And the civil always stay around the 5, 6, or 7. The location cannot be changed, because that is very old research field. But nowadays, in chemical engineering, it's just like the top first, right? But it also has the kind of cycle. So if you are wise enough, you really need to see future. That is very, very important. If you think that research field or that scheme is very popular, and then you are running that, and that means when you go out and go for that work, well, the popularity of that research field from new protocol actually started to be getting popular. So in this case, I think you'd better put some your effort on the classical civil or environmental engineering, because that is kind of better guaranteed job. So I think the U.S. really have good choice actually. Congratulations. Okay, general approach for the design of breaker. The first thing, what you should do is, the first thing, obtain rate equation. Well, RA, maybe DCA or DT, like that, this type of the rate equation. And we already have run the order of the kinetics, right? So it could be CA or CB, like that. So the first thing, obtain this rate equation, because the reaction mechanics is very, very important. So think about that. You want to brew beer in your home or in your dormitory, which is totally illegal. Don't do that. This is just kind of example's sake. All right. So you want to add some, microorganism, and you want to add hops, and you want to add barley. You need to design this one very well, because these can wreck each other, right? So it can be evaporated, fermented, and you should have enough space for this reaction, and you should have enough pressure for this material, right? So now using the reaction relative to these chemicals, including microorganisms, the first time you really need to obtain the reaction kinetic at first time. This is the reason why you guys want to obtain setup rate equation about the kinetic reaction for this designing of a reactor, all right? And then what you should do is you want to know the amount of all of the chemicals, and you want to know the final products amount. This is very, very important. And maybe depending on your preference, you want to higher or lower concentration of products, right? So what you want to do as a next step is define boundary condition. Well, there are two types, boundary and initial conditions. Well, as an initial condition, this is the Becher vector of cat, and you can add microorganism, and you want to add hops, and you want to add water, right? So as an initial condition, you want to know the concentration of microorganism, and you want to know the concentration of hops, and you want to know water is kind of very big mass. So we don't want to know the concentration. We just use it as a volume, right? And then the final could be you want to know the concentration of beer, right? You don't want to know the concentration of hops and the concentration of microorganisms for brewing beer, right? So mostly this one. The boundary condition, this could be the volume. These are the initial and final boundary condition like this. And then for the designing of the reactor, set up mass balance equation. Well, you guys already know how to set up the mass balance equation when you did the photochemical smoke and for the concentration calculation of acid rain, right? You set up the whole tragic balance of the cation and anions, and then you replace the concentration by any other chemical species. So finally, you have H plus equation as a linear or multiple algebra. So you can calculate the concentration. But this is a little bit different. So here, we simply set up the mass balance. This is very, very simple and straightforward, and it can be used for your bed program. Look at this. The amount accumulated in the system equals the amount flow in and the amount flow out and then the amount formed by the reaction and the amount lost by the reaction. This is simple, right? Think about that. This is a nice bowl of rice, and if you are caring about your, body weight, this is very, very important. You need to check the amount accumulated, right? So think about that. If you take one bowl of rice, this could be, include this amount flow in, right? And then maybe in the morning or during the day, maybe there is bowel movement, right? So it could be the amount out, actually. In stomach or in internal organ, there is kind of biochemical reaction. So the bowl of rice, or that could be a piece of the bacon or chicken, chicken, or even the beer from this can be consumed. And these are all kind of chemical compounds. So these chemical compounds actually in stomach, in internal organ, it can be, have some kind of biochemical reaction. So this can be form a new type of, protein or lipid, fat, or any type of carbohydrate. This can be actually formed in your body. It can be accumulated, right? So formed could be plus. But you guys are very smart, and you want to stay very lean, just like me, and you want to go out and take 10-kilometer run or maybe 2 or 3 kilometer of swim. And in this case, the accumulated fat by direction can be consumed, lost. Right. So this actually considered as the amount lost by direction, actually. Eating this one and losing by direction in stomach, that is totally impossible. So don't purchase some kind of, what is that kind of health diet pill. I actually don't believe that, Well, it can work as a kind of, catalyst to degrade this carbohydrate fast. Well, that could be, but that also can be, contained as amount protein. So don't do it. The best good thing is using this one. What is that? Go out and run, swim and run. Well, direction, your body actually reacts with this accumulated, fats, protein, and carbohydrate. You can burn all of this by direction, and this is minus. So if you want to have a very lean body, this diet program is very, very easy. Just give some stress on this one. And put this one very small. Right. So even you can have minus, body weight. I really need that. Done it, and But there is kind of some weak point because this is just a mass balance. But lipids and carbohydrate and these include calories, right? So the mass are always not proportional to the calories. Think about that. One bowl of rice, the same amount of chicken fat. Which one do you want to take? Maybe this one, right? Because you are smart enough. This one can, actually good for your health, and these are ruining your life actually. Because this includes calories. So if you really want to do some more, good diet, there is kind of another balance for energy. We call it energy balance. But in the environmental system and environmental science and engineering, you don't want to check the energy balance. Just mass balance is enough. All right? Okay, and step rule. Replace items in mass balance by rate relation. So using these rate relation, set up at first stage, just put it here, and then you can have nice mass balance with one variable. Well, as you already did for the calculation of the pH of acid rain. Right. 그러니까 이게 먹으면서 살 뺀다는 말은 이게 정말 거짓말인 거고, 그렇지? 그러니까 다이어트를 갖다가 하려면 여러분 절대 그 운동만 해서는 다이어트가 안 됩니다. 그러니까 음식을 조절을 해야 돼요. 저녁을 갖다가 안 먹으면 몸무게 쫙쫙 빠져요. 특히 그러니까 굉장히 심플하죠. 마스 밸런스는 여러분 생각해보면 딱 나오는 거잖아, 그렇지? 근데 이제 에너지 밸런스까지 여러분들이 아마 생각을 갖다 한다면은 정말 다이어트 잘할 수 있어. 그러니까 배고프잖아. 배고플 때 그러니까 칼로리가 적은 거. 칼로리가라는 말은 뭐냐면 몸에 리피드를 갖다가 더 많이 축적을 갖다 한다는 거거든요. 근데 이제 채소라든가 카보하이드레이트 같은 당분을 갖다가 여러분 섭취를 안 하면 그와 같은 그러니까 이 컴플렉세이션을 갖다 끊어주는 겁니다. 그러니까 어떻게 돼? 먹으면 바로 이렇게 바우얼 무브먼트 때문에 나오죠. 그래서 저녁을 갖다가 여러분 만약에 내가 얘기하는데 당근을 갖다가 한 30개를 사요. 30개. 당근하고 또 뭐가 좋으냐면 같이 오이. 그 두 개를 갖다가 저녁에 한 7시, 6시 정도에서 드시고 한 30일 정도를 갖다가 그렇게 그런데 아침, 점심은 드죠. 아침, 점심 먹고 싶은 만큼 먹고 6시에 하여튼 그 저녁으로 그 자기 양만큼을 갖다가 들고 한 달만 여러분 그렇게 있으면요 몸무게 거짓말 안 하고 7kg 빠집니다. 7kg. 그러니까 얼굴에서 광채가 빛이 나요 막. 정말 그러니까 한 1, 2주는 여러분 얼굴이 썩어 들어가는 거예요. 근데 이제 몸이 이 어저스팅을 하잖아요. 어저스팅을 하면서 이제 얘가 이제는 옛날에는 마구마구 먹더니만 이제는 이것밖에 없네. 컴플렉세이션 안 해도 되겠네. 그러니까 지가 알아서 이제 다운 사이즈만 하고 스토먹 자체도 크게 맞도록 변하고 그리고 한 가지 이제 이것의 좋은 점은 뭐냐면 배가 고프잖아. 배가 고프면 이 저녁도 먹고 싶은 만큼 당근을 갖다 드시면 돼요. 당근 한 6개 내지 7개 한번 먹어봐. 이건 정말 배가 든든한 게요. 다음날 아침에 일어나면 얼굴이 하얘져 그냥 표가 때문에. 그러니까 당근이 참 그렇게 좋은 겁니다. 당근하고 오일을 이용해서 한 달만 여러분 한번 해보십시오. 만약에 안 되면 고발해도 돼요. 특허 걸어놓은 건 없기 때문에. 근데 이제 리피드나 이제 그 이후에 이제 어떻게 회복하냐는 걸 이제 그 다음에 가서 또 알려줄게요. 오케이. Get back to work. Let's some example. So before starting the example, I'd like to talk more about the types of record. Well, we already have talked. There is batch record. Batch. I think you guys already heard about the batch. Batch is kind of one, amount for the production, and the other one is continuous. Well, there is because continuous is kind of very productive system. Batch is kind of just a 1/1 system, right? Sometimes 1/2 system or 1/3 system can be made. A mother can just like the batch system, right? So 1/1, maybe 1/2 twins for triplets like that. But continuous, you can put, you can have any amount as you want. So most of the chemical, environmental, or even civil engineers actually have a strong interest in developing continuous record. There is some plug flow reactor called PFR, and there is a completely mixed reactor, CMR, and there is kind of dispersed PFR, plug flow reactor. And continuous reactor in series. Think about that. Well, there is very big, V1 reactor. This is continuous actually. This is a mixer. But well, if you just want to make it the reactor smaller, let's say V1, V2, V3, and then do the same thing, like this. Which one could be better? Most of the people think this one, right? But we don't know. It depends on the direction characteristic, actually. So sometimes you can do it this continuous flow reactor in series, or sometimes you want to use just a simple one continuous stirred reactor. Depends on the direction characteristics. Okay. Now let's start to design the batch reactor. And let's say direction was A to B. I think I'd like to stop here. Okay, guys. Any question and any concerns or any comments? Well, some of you may be very wondering. Well, I just purchased the book, but why, Professor, you didn't follow the order of the book? Well, I will, actually, I will. The problem is, I don't think I can cover whole materials of the environmental engineering book. So I will take each part and then reorganize by the importance. So we will see. We will see how much we can cover for the environmental engineering. But we definitely can do for the reaction and the reactor design, which is very important for the environmental engineer. Then we will move to the some systems for the each different contamination scenario. For example, air pollution. There may be some different type of the environmental equipments. I will introduce you for that. And for the water treatment and wastewater treatment, I will introduce such wastewater treatment and water treatment equipments and plant. And also for the groundwater and soil contamination, I will also introduce the technologies for the remediation. I think that would be it for the semester. And then, if I really have time for, I will give you some tips how to earn money as an environmental consultant. Well, this is very, very important, you guys. Never ever say, I'm a student. I have much time before going out to earn money. Well, this is the time you guys need to start to earn money, right? Because, and also you are in the engineering, you don't think, you never ever think, have such kind of stupid attitude. I will give some environmental, scenario, an episode, and then how to consult those problems using whole knowledges we have run from the first day. Then I will introduce you the tactics and what you should do as an environmental consultant. This is very, very important. Think about that. If you just explain your knowledge in to your client, I don't think that is, right tactic. What you should do is, as an environmental consultant, you need to know what he wants. Important thing is it rich, or is she poor, or what kind of environmental problem they have. That is very, very important. It is just like the clerk at the jewelry shop. The first time went to see the clients, and she or he, the client, need to know what condition they have. Do they want to purchase diamonds or just gold, ring? Well, you guys really need to have different tactics to sell diamonds and ring, depending on the client's situation. I will talk to you later in case I have time. Right? Okay, anything else you want to talk with me?
Professor, could you suppose lecture notes on?
No, this is just a lecture note. So you need to write, you will make your lecture note. Right?
Yeah.
All right, enjoy the student festival. Come.